my next episode of Memos to the President, I'm sharing with all of you a conversation I had on stage with Jack Hidary, founder and CEO of one of the leading quantum companies that we have in the United States.
The DoD concluded many years ago that navigating with the magnetic field of the Earth is the only way 24/7 in all terrain, in all weather conditions, at all altitudes, and also subsea to be able to navigate this planet. There is a unique fingerprint of our Earth. Every square meter of our Earth, right here below us, about 60 feet below us, is the bedrock, is the crustal field of our Earth, does not change, changes over 500 million years.
He had an incredible presentation on stage, and then we followed with a more insightful conversation during the AI Expo. I hope you'll enjoy this episode as much as I enjoyed interviewing Jack on stage.
Please welcome Jack Hidary, CEO of SandboxAQ, for a fireside chat on delivering quantum advantage with Ylli, President of SCSP.
Hi, everybody. It's me again. It's really an honor to have Jack here today, but we're not going to do a traditional Q&A first because I want Jack to go through some slides. Obviously, he's the CEO of one of the major quantum companies. One thing, Jack, that I didn't tell you is that everywhere I go, people tell me, do you know SandboxAQ? I was like, yeah, I just happen to know Jack. But anyway, over to you, Jack, for some slides, and then we can continue the conversation.
Thanks, Ylli. Great to be here. Share the stage with so many great leaders from our armed forces. Thank you for your service. I want to share with you just a couple of ideas first to kick off and hopefully be a bit provocative in terms of what is possible now. I think everyone here knows about large language models. Large language models certainly have a great broad application space in terms of summarizing documents, looking for patterns in text. But the bulk of our economy and the bulk of what we need to do to defend our country and our allies is quantitative in nature. When we think about new materials for missiles, energetics, tanks, lightweighting vehicles, this is all to do with quantitative information, molecular information. When we think about cyber, this is streams of quantitative data. When we think about sensing, this is quantitative data. In general, a large language model trained on Reddit and cat pictures is not what you want to defend the country as you're looking at cyber, defense, or very other applications. And so when we look at the complementarity of large language models on the left, large quantitative models, LQMs, on the right, you can see the clear distinction. We need large language models. Everyone, please use them. They're being used across the DoD right now, which is awesome. But large quantitative models are the ones that really make the difference in terms of how we go offensive and how we defend ourselves. These are some of the applications that hopefully Ylli, you and I will talk about on the right side here. We've raised about $1 billion in capital, and I mention that to indicate that there's strong interest among the investor base. The largest investors, T. Rowe Price, Alger, Guggenheim, the kind of investors that really are looking for key advantage and giving ourselves and our allies asymmetric advantage. And hopefully in our fireside chat we can expand on why are investors now gravitating towards this deeper tech pool with Anduril, ourselves, and many others in that category. We also include Google and NVIDIA, who just recently joined our round. Great to see them as well. So what are some of the application spaces that we'll talk about today? Batteries for the warfighter. When we think about the warfighter and the pack that they carry, if we can make that battery lighter, more power dense, we can actually deliver more for that warfighter. If we can have a better battery for that tank, we can be more fuel efficient, combining both petrol and batteries. Advanced materials, both in missiles, UAVs, and other applications. And of course, we'll talk today about agents. So large language models, again, useful, but commoditized at this point. The data is public. It's the World Wide Web. We know all that data. Mostly we've hit that data wall right now. We've hit peak data. The transformers, the models, again, all public. So again, very useful, gotta use it, but does not give us any advantage. When we look at China right now, China is all in on AI, both as a government and in terms of their AI ecosystem as well. We have the dragons and the tigers, and hopefully we can come back to that in our conversation. It's not just about DeepSeek, Qianwen, which means 1,000 questions in Mandarin, now has beat DeepSeek on many key benchmarks. So we're seeing a very robust investment on the part of the PRC in this area. Beyond AI, they're also doubling down on quantum. This is Pan Jianwei. Pan Jianwei is the Robert Oppenheimer of this Quantum Manhattan project. It's a project with more than 2,000 scientists and engineers. It is funded with $15 billion over the next few years of support from Xi Jinping. And the aim of this project is threefold. One, crack the cybersecurity and encryption of the West. Crack that with quantum computers. They have 8 different quantum computer types that they're working on, 4 main ones and 4 auxiliary ones. There's red team, blue teaming going on there to achieve their goal of cracking RSA and other cybersecurity standards that we use to defend ourselves. Number 2, they're creating a network that is indestructible from the point of view of quantum attack. So this is a quantum-safe network that we will not be able to read or attack into. And 3, quantum sensing, which we'll talk about here today. So we'll get to that. The data for LQMs is not the web. It is equation-based, it's physics-based, it's based on the real world. I'll give you just one application, and then we'll go to our fireside chat. We all know in this room about GPS jamming, GPS spoofing. And beyond just spoofing and jamming, we know that when things go kinetic, we will assume that the PRC or whoever the other party is will knock our satellites out of the sky. You must assume that you will not have GPS at all. You can harden it all you want. It will not be in the sky in a kinetic scenario. And so what can you do about that? The DoD concluded many years ago that navigating with the magnetic field of the Earth is the only way 24/7 in all terrain, in all weather conditions, at all altitudes, and also subsea to be able to navigate this planet. There is a unique fingerprint of our Earth. Every square meter of our Earth, right here below us, about 60 feet below us, is the bedrock, is the crustal field of our Earth, does not change, changes over 500 million years. If your flight is less than 500 million years, you're okay using this crustal field. And what we've done is built the first usable real-time navigation tool. It's been on C-17s, it's been with AMC. We have several members of AMC here at this conference, Air Mobility Command, and proven over hundreds of hours of flight that this is a real-time device that is able to use AI and quantum sensors to navigate with the Earth's magnetic field. This is absolute positioning, not dead reckoning. And so it takes care of that drift that you have normally with INS, with inertial navigation systems. Here we are in the final real-time test with AMC on a C-17. So I'll conclude with that for now. We can go to some more slides during the fireside chat. But the message I want to leave you with is we're just beginning in the world of AI. Large language models, very useful, absolute table stakes, need to use those. But the asymmetric advantage in cybersecurity, in navigation and PNT, in energetics, in materials, this comes from quantitative AI. Thank you.
Amazing. Jack, I mean, seriously, the energy you bring and the passion, it resonates. I mean, I've seen you, I've watched you. I mean, the company you've built is really amazing. Let's unpack everything little by little. First, I care about US-China competition. Can you give us an assessment of who is ahead? This is the question we get all the time. We do our own assessments, but you are in the middle of the arena. Who do you think is ahead in the quantum competition?
Sure, let me go to a slide on that. I happen to have one. Thanks, Ylli. And let me talk about AI first, then go to quantum. On the AI side, it's very clear that on large language models, there is no moat. There is no way to have a defensive moat on the large language model side. The data is open, and the models are open. DeepSeek, whatever you think about how much they spent, let's say they spent hundreds of millions of dollars, and not the 5 or 10 that they said publicly. It still means that there is no moat in terms of that. So you must assume that your adversary, your peers and near peers, have the same technology you do in the large language model space. The good news is that the more impactful space is on the quantitative side. And that's where we in the US and our allies can have distinct asymmetric advantage if we press our advantage right now. That is a space when the data is proprietary, Ylli. The data is not from the public web. It is driven by experiments and equations and others that we keep proprietary and do not put on the web. This applies to new materials for tanks, for example, where right now the M1 tank is being designed, the next generation. The need right now is to make that tank 20 to 30% lighter. We need to lop off 20 tons from that tank to make it agile enough to work in the Indo-Pacific region, Indo-PACOM as an example. A C-17 is big enough, volume-wise, to take 4 of those tanks, but weight-wise, only 1. And so we've got to change the game there with new material science. That's quantitative AI. So on AI, on LLMs, parity right now with essential parity with the PRC companies and also backed by the government. On LQMs, we have a distinct advantage right now, ourselves and our allies. Let's now turn to this slide here. Ylli, what I'm showing on this slide, there are 8 different main ways to build a quantum computer. They each have pros and cons. Some are room temperature. Such as neutral atoms is essentially a room temperature approach. It's one that has scaled the most right now. If you look at the numbers of qubits right now that you can produce, it's still small numbers, but relative to the others, the most is neutral atoms right now. There are 4 Western companies building neutral atom computers, Pascal in France, we have Atom Computing in the US, we have Q-ERA, Q-U-E-R-A, spin out of MIT and Harvard in Cambridge. And so there's good examples on the West, but the difference is that the Chinese have a Manhattan Project on this. So we're actually looking not just at tech versus tech, Ylli. What's fascinating about this case study, probably to be written up by your organization in the next year, is that we have 2 different systems competing. Right. We have a system of open innovation in the United States, university-led, and then venture capital-driven, and then some of the hyperscalers, obviously, Google, Amazon, IBM, and Microsoft each have programs here. But in China, in the PRC, we have Xi Jinping, and then led by Pan Jianwei, a very respected physicist, we have a Manhattan Project. Literally, if you look at the Los Alamos Project and copy and paste it, you literally even have the Matt Damon character. If people remember, Matt Damon in Oppenheimer played General Leslie Grove, and that is played here by General Yin Hao, who has a PhD in engineering and is overseeing, and essentially that project has become part of the PLA. It's been militarized at this point. So in terms of who's ahead, it's hard to say exactly right now, but let me say this. The PRC has met and exceeded every milestone they've made publicly. They've published in peer-reviewed papers, they've announced, because they're very proud of this particular effort, and they've particularly focused on photonic, which is similar to what we have in the US with PsiQuantum, a great effort in the US, but that's just one company. They have a whole government entity on that. Ion trap, which is similar to the public company IonQ. Superconducting, which is what Google is doing, Amazon's doing, and IBM is doing. And then neutral atom, I mentioned already. Those are the 4 main ones, and they have 4 auxiliary ones as well. I think that we have to bet, you know, Sun Tzu taught us never underestimate your enemy, respect your enemy. We must assume they will hit their target of cracking RSA in a very near-term time frame.
Can you talk briefly about implications if they get there first?
Sure. Number one, they will not tell us that they got there. We in the US and the UK did not announce to the Germans that we cracked Enigma back in World War II. We kept that a secret. We even let some missions go ahead of theirs to not let them know that we had cracked Enigma. I think something similar is going to happen here, where the PRC, I think, may be getting to a computer, because let's remember, they can take shortcuts. We in the US and the West are not building specific quantum computers to crack RSA. We're building general purpose computers, one application of which is Shor's algorithm, which can crack RSA, ECC, and other algos. But they are building purpose-built computers. So you can actually design it just for that. And so the chances are they may get there ahead of time, but not let us know. That means that we have to batten down the hatches today because of store now, decrypt later. Every time you hear that an adversary, North Korea, PRC, Iran, others are in our electric grid, are in our telco grid, are in our infrastructure, banking, so on and so forth, that means they have the ability to suck and exfiltrate information out, store it, and when they have that scaled quantum computer, they can then read and decrypt that. That's store now decrypt later. So we have to assume that any data we have today that is not with the new NIST standards, here's the good news, Ylli. Finally, we have some good news.
And I want to ask you about this because we're in Washington, so obviously, what are some of the signs you have seen our government move in the right direction, and what would you like them to do even more?
Even more. I have a good news story on government. Across multiple administrations, Democrat and Republican, we, the United States, has successfully looked for, searched, adopted, and now standardized 4 new security standards that withstand quantum attack. Those are now the NIST standards, National Institute of Standards and Technology, part of the Department of Commerce. Secretary Lutnick has been a big proponent of this, along with his predecessors, both from Trump 1 and from Biden. So this has been a bipartisan effort. Rare to see that sometimes, but this has been a great example of working together, not just government, but also with stakeholders in academia and in the corporate world as well, examples ourselves. 2 of the 4 standards, I'm proud to say, are resulting from work at SandboxAQ, 2 of the 4 global standards. These are free, open standards to be used by all of our allies, and I hope, and this is where to the second part of your question, I hope that we can see intense focus on the part of the administration now as they're focusing on cyber, as they're focusing on this key area. I hope that the various bodies, we're about, I think, to get the confirmation of Sean Cancross, who's the new National Cyber Director. Sean is very experienced in these areas, and I think with his leadership, we will see a renewed focus on cyber and protecting ourselves from this particular attack.
Excellent. In your slides, you talked about how AI and quantum can give us a new defensive advantages, especially in the P&T side. Can you elaborate more about that?
Yeah, no, I'd like to do that. This is a critical area. When we think about positioning and navigation, I'll just go to this slide over here. We think about AQ Nav. We need AI and quantum together. Why do you need AI and quantum together? Well, the magnetic field of our Earth is very, very weak. Right? If I have a paperclip here, it doesn't get attracted to the magnetic field. It's so weak that it doesn't even attract that. And so to pick it up, we need these very sensitive sensors. Quantum is the one we use in this case. We fly it in real time on these planes, UAVs, so on and so forth. And then we need AI to interpret the signal. The signal is complex and coming at you fast, Ylli. There's a lot of information flowing out of these sensors. So good news is they're very sensitive. Challenge is a lot of info. That's where you need quantitative AI. So it's that meld of A and Q together. That's what really rocks the boat over here. Now, detection, navigation is one thing in terms of the airspace. The next frontier is maritime. We know that GPS, even if you have the signal, does not penetrate more than 1 meter below the surface of the sea. And so if you're in a submarine situation, if you're on the surface, you want to detect things below you, you want to navigate, this is going to be the technology. So we foresee really the world's first time since GPS that we have a global navigation system that we can rely upon 24/7 in any terrain, in any weather condition. The other modalities that we try to use as a country, be it celestial, be it visible, looking at trees and patterns, are not reliable in all terrains, particularly Indo-PACOM. Given the Secretary's recent conversation and discussion in Singapore, I'll refer to his remarks, and you can check those out.
No, I asked both the Vice President of Taiwan this morning about the remarks. I just asked the Chief of Staff of the Air Force about the remarks because I think they were important.
They're very timely. Yeah. So the Secretary made it clear what we need to do in Indo-PACOM. Admiral Paparo, who heads up Indo-PACOM as the battle commandant, is keenly aware of this. We've been testing with him and doing all the trials with him, which is very important as well. So we are ready with this asymmetric advantage, an advantage that gives us the visibility in all conditions of suppression, whereas the enemy then has to assume that we can fly and go kinetic in any kind of condition.
Let's talk about AI and cyber a little bit.
Yeah.
You mentioned about the Chinese efforts, and we didn't mention Salt Typhoon, Wall Typhoon, all the recent hacking, I think, incidents we've had. This is the age and the year of AI agents.
Yes.
Will they hurt or help in this space?
It's a great question. It's a double-edged sword. AI agents are starting to proliferate everywhere. The low estimates, Ylli, The low estimates are that we're going to have 1 billion to 10 billion agents running around networks in the next 5 to 7 years. That's the low estimates. Right. Mark Benioff has put a number out there of several billion agents. Others have put the numbers out there. But let's just say it's a big footprint. The problem, the challenge with AI agents is we give AI agents pieces of code more autonomy than we've ever, as humans, given any piece of code in the history of computing. Normally, code is part of a very well-regulated workflow, and we understand everything that it's doing in a very, very key, detailed, compliant way. With AI agents, we're giving them empowering things as maybe as benign as, hey, please go get me an airplane ticket using these constraints, to, hey, can you go find some interesting vulnerabilities or things like that. AI agents form a much bigger, Ylli, attack surface than we've ever had in the cyberspace. And so AI agents help and hurt. They can both help us in finding vulnerabilities, but given the proliferation of AI agents and the lack of experience that humans have with giving this amount of autonomy, imagine AI agents running around a hospital. Hospitals are the #1 attack penetration target of ransomware in the United States. Right. Last year, 2024, previous year, 2023, hospitals, #1 target. Why? They must pay. They must get back on. Right. 93% of all hospitals attacked by ransomware pay the ransom in Bitcoin. And so this is something that we must embrace. We're giving away our software, our cybersecurity software, for 0 license fees or low license fees to medical centers, nonprofit medical centers. We care very deeply about this part of our critical national infrastructure. We must not let our hospitals go down. But it also means, from a DoD perspective, from also the civilian agency perspective, that we must make sure we are protecting ourselves, not just from the quantum attack, we did discuss that, but on screen here, I'm talking about the AI agents, we're talking about certificates, we're talking about the issues that come from hashing algorithms as well. Every network we're in, Ylli, every big bank, every big agency in the government that we are happy to serve, we find old hashing algos. And what does that mean, to translate for the audience? It means that the password files that are supposed to be in gobbledygook, protected against hackers, are actually clear text. You can actually read them because they're in MD5 or SHA-1, which, although SHA stands for Secure Hashing Algo #1, it is not secure. It was broken in 2008. So this is something of extreme importance. And again, we're encouraging and working with the administration to make sure we can really close the loop on the cyber issue.
You had a really good slide to turn this conversation a little bit on the positive outcomes.
Yes.
Like the impact of AI, LQMs on new material science.
Yes.
Can you tell us some of the things that you might see emerge in this field?
Yeah. This is, to me, one of the most important areas. I'll touch first upon new medicines and drugs. It's important both from a defense perspective, because we could get attacked by biotechnology. The new Undersecretary of R&E is Emil Michael, comes from the tech space. One of his priorities, of course, AI, quantum, but also biotechnology is one of the key pillars of R&E, as it should be. Biotech is a vector of both offense and potentially defense as well. And so it's very important that we have the simulation capabilities, Ylli, to simulate the biological world down to the electron level. That capability for humans to do that only started 36 months ago. Only 36 months ago has NVIDIA compute, other compute from Alphabet and others, combined with the software that we wrote, that hardware-software stack, given humans the superpower to actually simulate our world down to that level. So that's in the drug discovery space, and again, you can think about bioattack and biodefense. But let's now talk about material science, your question about that. Whether it be a tank that has to be lopped off 20 tons of, right, to make it more agile, right, and take it from the European theater, where maybe it was designed for, to a more agile, mobile, Indo-PACOM, other battle commandants, or we're talking about a missile, to lightweight that, to go hypersonic, or whether we're talking about energetics, be it explosives, fuel, so on and so forth. These are key areas where, again, the superpower of being able to model that world down to the electron level on GPUs. This is using quantum equations on NVIDIA and other GPUs. That is the breakthrough that just happened 36 months ago. So when we are in conversation, be it with the civilian sector, automotive, Airbus, Boeing, so on and so forth, or the defense sector, this is a critical superpower that can take model development from 5, 10 years down to 2 years and give us new materials that no human can ever come up with. We're talking about, Ylli, a design space that is a palette of hundreds of millions of possible combinations of materials versus just a few dozen. And of course, we always then check it in the real world and iterate in that make, design, execute cycle.
Incredible. You know, in the last couple of years, I've seen sort of the emergence of the quantum ecosystem. You have a couple of companies that are really good. How do you assess just the overall ecosystem where you live daily?
Yeah. Let's talk about that, and also if we can talk then about human capital.
Absolutely,
I'd like to also address
that's a
that for
great
AI
important point,
and quantum. But let me talk about the ecosystem. There's both several public companies and private companies in the quantum ecosystem. The good news is that the hyperscaler companies, be it Amazon, Azure, Microsoft, Alphabet, Google, IBM, many others, even Oracle now, starting to put big dollars into the quantum ecosystem. Now, one thing I would note, though, is that there's been an overweighting on quantum computing and an underweighting on quantum sensing. We just showed on screen an example of quantum sensing working today, flying today with AMC. We don't need to scale those further. They're already scaled. We don't need error correction for quantum sensors. They're here today. And so we've been the global pace setter in quantum sensing. So just to share with the audience here and on video that quantum is bigger than just quantum computing. So when we talk about the ecosystem, it's quantum computing, it's quantum sensing, and it's quantum communications. Those are the 3 pillars of the quantum ecosystem. I think it's pretty healthy. We're seeing billions of dollars move into it from the US venture capital, growth capital, and now public company perspective. But to keep pace, we're going to need to really double down on that. And I think Michael Kratsios of OSTP, who literally co-wrote the National Quantum Initiative in the first Trump administration, is the guy who can really help try to pull this together along with others in the administration. So that's on the quantum ecosystem. When we talk about human capital, I want to strike a note of concern there. I think that what's critical that we think about on the AI side, we need to be training and attracting the best and brightest to our companies. We're a company mainly of PhDs and engineers. 85% of the people at SandboxAQ are either a PhD in a certain discipline, such as chemistry, material science, and so forth, or a software engineer coding up the AI. Very technical team, similar to what we were inside Alphabet before we spun out. But in general, that means that we need to be training those people in master's and PhD programs. We at SandboxAQ, we don't take anything for granted. We go into 45 universities here in the US and some abroad, and we start co-training those students while they're still students.
That's incredible.
I can't wait, Ylli, till they graduate and find out that they have no real world skills, right? Yeah. We did that first when I was back at Alphabet. I was like, hey, this is too late. We're getting them too late. Yeah. We got to get earlier in the cheese-making process.
How many numbers you get out of these training?
So it's a great question. Over the past 7 years since I launched it, first at Google and then now at SandboxAQ, we've trained more than 570 master's and PhD students. I'm very proud of that number. We only give offers to 2% of those to join SandboxAQ, but the others we encourage and we help get them great jobs in the ecosystem, both AI, material science, quantum, biotech, and other parts of the ecosystem. I believe that over time, the next 10, 20 years, many of them will come and cycle through SandboxAQ with even more experience. So that's millions of dollars on our part of investment, but I think it's worthwhile investment, Ylli, because we need to be investing in these folks. Only a handful of people are needed to suddenly change the game from an asymmetric point of view. Our concern is that our adversaries, peers, and near peers are investing right now in these kinds of programs in their countries, and it's critical that we double down on these individuals.
How do you assess the status of our allies and partners in the quantum race?
Great question. When you look at Europe, you have a number of areas of centers of strength. You have Copenhagen, Denmark. You have the Dutch ecosystem. The Dutch ecosystem is known as Quantum Delta, and the word Delta stands for 5 different cities in the Netherlands. So check that out. You can test yourself if you know the cities in the Netherlands. The A stands for Amsterdam, so that's an easy one. But I challenge you to the other ones. D is for Delft, so on and so forth. So Netherlands, Denmark, with its long history from Niels Bohr in quantum, is investing a lot. The Novo Foundation, which owns the majority of Novo Nordisk with the Ozempic. So good news is that all your Ozempic usage, that revenue is going towards quantum inside Denmark. That's where that money is being translated to right now with that long history of quantum advantage there. When we look at France, we're seeing really good investment. Pascal, I mentioned as a company, a number of other companies, Alice and Bob and things like that in France. And then we're seeing some others as well. UK has a strong program, but again, this is going to take for us to really meet the challenge and step up to the PRC gauntlet that has been thrown down. It's going to take a lot of collaboration to make this happen.
Absolutely. I have 2 quick questions because I think we're getting close to the end.
Yeah.
Number one is, in 3 years, where do you want to see the quantum space? What do you think are the biggest milestones? Because ever since I've followed quantum, you know, I think we've moved beyond the quantum is 7 to 10 years away. I think now we're talking about, you know, this decade seeing major breakthroughs in quantum. So, you know, from your vantage point, 3 years from now, where do you want to be?
Yeah. Let me answer that. And also, I don't know if Lisa back there can show us the video in a minute that we have on agents, because I think it's important to talk about how agents, AI agents, interface with quantum as well. I think your assessment is correct, Ylli. We've seen a quickening of pace. We've seen announcements from Amazon, Microsoft, Google, many others in the space. You've seen a basket of stocks that are public companies now, IonQ and others. Quantinuum, our friends there, probably will file to go public in the next 6 to 12 months. That's the former Honeywell computer, now called Quantinuum. I think that will be successful. And so we're seeing both public and private companies really start to move. The number one thing, of course, will be error correction and high fidelity qubits on the quantum computing side. We're seeing big milestones being met. Is there more work to be done? Yes, there is, but it's now down to engineering, and it's now to scale. Will all 8 of those ways of building quantum computers make it to the finish line? Maybe not, but I believe at least 3 will make it. I think neutral atom will have good scale. I think superconducting will have good scale. Photonic has inherent scale because silicon photonics leverage the 60 years of the semiconductor industry. So I think 3 or 4 of these will definitely make it to the finish line. And finish line defined as a scalable, error-corrected quantum computer that can do both positive and unfortunately negative things as well. I also think it's important to look at AI agents. I don't know if we have that on screen, we can show that video, but AI agents, the ability for humans to hand a task to an agent and accelerate science and accelerate the ability for materials to move ahead, this is something that is unique to our time frame right now in the next 3 to 5 years. We're going to see the ability of agents to do a lot of the work and compress timelines from 10 years, 20 years. The average time it takes for a medicine to get to clinical trial is 10 years. Guess what's even worse? I was just in the Midwest at one of the largest chemical producers in our country, a material science provider to the DoD and defense industrial base. It takes 20 years on average to get a new catalyst that will lead to a new polymer, a new material. We are now using AI agents to bring that down, instead of 10, 20 years, down to literally 18 months. In some cases, we're even finding some of the initial solutions in under 90 days, and of course, it then needs testing, you know, in the real world. So this is something that I think will have a game-changing impact in terms of how we're going to see our world evolve. NVIDIA and the chip companies, be it Alphabet, be it Amazon, Microsoft, I know people mainly think of NVIDIA, and NVIDIA is one of our core partners, but look to an ecosystem of chips. I'm very proud of Jensen. Many of us in the quantum world sat down with Jensen over the last few months, and Jensen has embraced the quantum world. So the future, Ylli, is going to be CPU, GPU, QPU, quantum processing unit. And here we see an example of agents. A human has handed a molecule to the agent. The structural agent is now making 1 million versions, adding carbon, taking one away. The chemical property agent, Ylli, is checking the properties of that. Will it hit the target in the body? It's filtering it down with the filter agent to 3 that will then go to the actual lab, and then the cycle starts again. That whole cycle used to take about 2-3 years. We're now doing it about 8 to 9 days. Right? So this kind of game-changing impact is what's happening right now. I think it's great, Ylli, that you've brought together here at AI Expo the tech companies, the defense industrial base, the Pentagon, the leadership who protect us every day, and our allies. This is an important confluence and collaboration. Without this collaboration, we are not going to be able to meet the moment of the day put down by our adversaries.
Thanks so much, Jack. Thanks for bringing the energy. I want to end this. You know that we organize exchange to honor the legacy of Dr. Ash Carter. I know he was a big believer in SandboxAQ, so.
Yes. I was really happy to learn that this is in honor of Dr. Ash Carter. Ash was very close to us. He was one of our key advisors on our advisory board here. I see another member of our advisory board here, Teresa Shea, who knew Ash very well. Lloyd Dabbs is here, who knew Ash. Many in the audience here are friends of ours, colleagues of ours, and we all mourn him. I was with Ash, talking with Ash 3 days before he passed. He was very, very close with us, with Eric Schmidt, our chair, with myself. He gave us extremely good advice every moment of the day, advice that went beyond just our company. Ylli. He really saw the big picture. I think his wife, Stephanie, is here.
Stephanie is right there.
Stephanie, yeah. Stephanie, thank you so much for being here. It's an honor to pay tribute to Ash. We all loved him as a person. He was a great human, even before. He was a great defense thinker and doer. And he's one of those unique individuals in our lives, and we don't have many of those, that understood the deep science, but also was a pragmatist in getting stuff done. And we miss Ash very much.
Well said, Jack. Thank you so much. Please join me in a round of applause for Jack Hidary, please.